Greetings of the day, dear students. In this video, we are going to discuss about the Zener diode, and we will discuss what is the difference between an ordinary diode and Zener diode, and also we will see its circuit symbol, diode symbol, Zener diode symbol, its VI characteristics, Zener diode VI characteristics, and some applications and its advantages and disadvantages in this video. Right? If you observe, dear students, with respect to the ordinary diode and Zener diode, the major difference we will come across its doping. We will come across its doping. So how do you understand that? Doping means nothing but adding the impurities to the semiconducting material, either silicon or germanium. Now, if it is Zener diode, right? Now it is a heavily doped silicon or germanium diode. And one more point is it always gets operated in the reverse bias mode and in the breakdown region. But whereas our conventional diode, it will not operate in the breakdown region. Most of the times it will get operated in the forward bias mode. But whereas the Zener breakdown operates in the breakdown region. Now because of that, if any excess currents are there, those will be limited. The current will be limited by providing some external resistance, and the flow of current can be limited, and also the power dissipation capability of the diode can be limited with the help of external resistance. Right? With respect to the diode, we are having two types of breakdowns. One is the Zener breakdown and another one is the avalanche breakdown. Right? If it is Zener breakdown, it is mainly due to the because of the reverse bias applied voltage, right, across the depletion region. There will be the establishment of strong electric field. There will be strong electric field established across the depletion region. Because of that, what happens is this strong electric field will make, or it will make the covalent bonds to be broken. Because of that, all of a sudden there will be high flow of current because of the breakdown of the covalent bonds. Due to the strong electric field that is established across the depletion region, there will be the Zener breakdown. There will be Zener breakdown. But whereas if it is avalanche breakdown, it is mainly due to the kinetic energy. Kinetic energy. Out of these two breakdowns, right, one is due to the strong electric field, that is Zener breakdown, and another one is due to the kinetic energy of the minority charge carriers, right, in the PN junction diode. It leads to the avalanche breakdown. If you observe the diode symbol, this will be the symbol for the Zener diode. If it is ordinary diode, we will draw like this. The difference you can observe that it is just simply a straight line, but here it will be in the shape of a Z, like this. Of course, anode positive, right? Cathode negative, right? If it is forward bias, anode positive is connected to the positive terminal of the battery, negative is connected to the negative terminal of the battery, then it is forward bias. If it is reverse bias, negative is connected, anode is connected to the negative terminal of the battery, cathode is connected to the positive terminal of the battery, right? Then it will be under forward bias mode. Now if you observe its VI characteristics, right, observe on x-axis you have taken the forward biased voltage, on positive x-axis, right, on negative x-axis you will take the reverse biased voltage denoted with letter VR, and on positive y-axis you have taken the diode forward biased mode current IF, and on negative y-axis we will take the IR, reverse saturation current, IR, reverse saturation current. If you observe the magnitudes of current, the forward biased current will be in the order of milliamps, and if it is reverse biased current, it will be in the order of microamps. Now, if in the forward biased mode, you can observe up to this potential VB breakdown voltage of the diode, there is not there any conduction. Depending upon whether it is silicon or germanium made, okay, there will be the occurrence of the breakdown at some point 3 volts or some 0.7 volts, right? Now then at that time there will be all of a sudden a high conduction. Now the current starts increasing. Diode came into the conduction mode. Similarly, during the reverse biased mode also, up to certain point there won't be any conduction. Some small amount of current will be flowing. That is due to the minority charge carriers, right? And all of a sudden, the moment you cross the breakdown voltage Vz, Zener breakdown voltage Vz, all of a sudden there will be high conduction in the diode. High conduction in the diode, right? So this is the Zener breakdown region, right? And its impedance is given by delta Vz divided by delta Iz will give you the Zener impedance. And also you can observe the temperature coefficient of the diode will be generally negative, right? For Vz, Zener breakdown voltage below 5 volts, and the same temperature coefficient will be positive if the Zener breakdown voltage Vz is above 6 volts, right? Now the alpha Z is given by delta Vz divided by Vz bracket of T minus T naught into 100, right? So this is what all about the Zener diode. Now coming to its application, most of the times Zener diode is used as a voltage regulator to regulate the load voltage, right, at the value of Vz by acting as a bypass valve, right? And also it is used in the voltage reference circuits for wave shaping the circuits. And with respect to its advantages, there will be the control of flowing current. We can control the flow of current by connecting some external resistor in the circuit, right? And also because of its capability and obtainability, these are the two advantages we are having. And coming to the one disadvantage, the disadvantage is the Zener diode is having a poor voltage regulation, right? The percentage of change in voltage is poor. Voltage regulation, the change in voltage will be poor, right? So this is what all about a Zener diode, right? So dear students, please share this app with as many students, friends and classmates and juniors as possible to make this app reach more number of students, so that more number of students will get benefited. Okay, thank you.